Assalamu alaikum warahmatullahi ta'ala wabarakatuh. Bismillah ar-Rahman ar-Rahim. Ladies and gentlemen, let's continue our tutorials about our HVAC systems. In this video, we're going to complete our project. Here, this is the project. We have talked about the duct system and design and the rectangular ducts for this floor, the third floor, and here is the roof, and here is the air handling unit, and here is the duct. Okay, so the previous tutorial we talked about the same design but in Autocad 2D. In this video we're gonna complete this building, so we're gonna talk about the ceiling number 2. Here is the ceiling number 2. Okay, and we have the total CFM for the second floor is 8019 CFM, and the friction that we used 0.025. The total CFM for the second and the first floor is 16678. Okay, so here the duct system. And here we have to know the size of the duct that will be used for. It's going to be used for this floor or this level and the first level. So it is 16,678 CFM. So let's open the duct mate and to know what is the size of this duct. Okay, as you know, you have to enter all the things that you know, but for this tutorial we're gonna focus on the friction. Okay, the CFM 6678 and the foot per minute for the main duct. Okay, okay, this CFM is okay to use this. Okay, we have here two numbers, and it's okay to use this foot per minute for the main duct. Here the clear height is very big, and here make this 300 inch. Okay, be sure that this is right and this is still right. Okay, 26. So the aspect ratio 94.4 divided by 6.73. This 3.5. 3.5 is the maximum aspect ratio. It's okay, but try to decrease it. Make this 30. Notice that we will face some changes. 30, 81. So this is right, and this is right, and this is the footprint per minute. Okay, 81.4 divided by 30 is 2.7 is better. Okay, so the clear width 81. Go to Revit, and here is the duct. Level 2, and here is the round duct. No. The duct is radius elbow taps. Radius elbow tap. Okay, okay, click cancel, and here is our duct. Yeah, here is our duct that is round. Oval, rectangular, mirror elbow. 81.4. 0.4, so it's gonna be 82, and here is 30. Okay, so this is the main duct. Okay, and now we have to know what is gonna happen. We make it hidden. Okay, realistic. Level 3. Let's see the visibility. Range. View range is up to level 2. Make it up to level 3. Okay. Offset. Make it unlimited. Okay, let's see this. And here is our duct. Suppose that our duct will be like this. Okay, cancel. Okay, change, Control Z. Okay, here is our duct. Can move it. Just we have to know where is the duct. This duct can distribute the CFM for this floor, for this level, and the other level. Okay, and here's the level 3. Okay, okay. Okay, to be sure of the position of this duct, you may delete it and just measure the distance. Okay, suppose that you gonna make from here to here. This is 99128. 9128.9. Okay. One, two. Okay. You can make it here. 128.9. So this is the point. Okay. And go again. Okay, it's okay. Just you have to know where exactly the duct that you're gonna get the branch from it. Okay, so now this is the CFM. duct that is good for this level and the first level. Okay, now we're gonna use it for distributing CFM for this level, and we're only in this tutorial gonna talk about this zone 1, 2, 3, 4, and you can do the same for the other CFM room. Okay, here is the duct, but this was done by Autocad map, but we're not gonna do the same thing. So here is 514. Okay, here is the total CFM is 8019. So go to duct mate and see the CFM 8019. Okay, here the foot per minute, I think it's good for the main duct. And now we're gonna use the this tutorial is about the equivalent diameter round ducts. So we're gonna use the round ducts 40. Okay, so this is the duct. I'm gonna use here many tabs, short radius tabs. Suppose that here 40. Okay, we're gonna take a branch from it. Okay, this is what we need. Check out the 3D. Just orbit to make sure that this is all right. Okay, okay. So what I mean that you can add a duct from here to here. No. No, it's going to be a problem. There is it's better to draw it like this. We need 82 and 30 from here. Okay, so get the duct, and from here exactly. So this duct I don't want it. Okay, it's just important for the 3D. Now we located this, so we need the same duct to be from here. Oh, you will face some problems, so please have patience. Okay. I just need to add the same duct size. No. No, the offset 2797.2. 2797.2. So this is the offset. Okay. To avoid this problem, we're gonna do something. Just extend this duct. Okay, so this is very good. Let's see what is the offset of this duct. It's 2797. Okay, this is what we need. Okay, also this duct, we're gonna make it radius radius. We're gonna make it radius. Okay, Control Z. So let's see what's gonna happen now. and here is the duct, radius, elbow. Okay, you have to be sure of the navigation. Okay, and this is okay. So this is very important to be sure of everything to avoid the modifications later. Okay, gentlemen, this is the duct that for the second floor and the first floor. Now we are gonna use the ducts that we did here is 40 for the third, so use this 40 until it becomes green. Okay, go to the ceiling too, and here is the exact drawing. Okay, and here we can make this, increase it with this duct, make it okay. So this is the main duct that is gonna be used for the distribution for this zone 2, 3, 4, and the other 4 zones. So the same duct may be increased like this. So now we need to know the total CFM for this area, including the diffusers. We have here also some diffusers, so 514 plus 123 3 0.5 plus multiplied by 2 123 0.5 multiplied by 2 plus 330 plus 538 plus 560. It's gonna be 4 okay, minus, so 440 3. So the duct is 4403 for this area. So this area needs total CFM 4403. Okay, and here is the foot per minute and the equivalent diameter 32. Go Revit, and we're gonna use 32. This is the duct, and we're gonna need this duct to get the branches from it to distribute the air to this zone and this, and the two distributions here area. Okay, now let's take a look on the diffuser. 1230.5 is already 600. Okay, I'm gonna use an arrow terminal here. Neck. Okay, 200 diameters. 2797. Okay, now we have this distribution. Also, you can measure the distance, but for this tutorial, we're gonna focus on the main things. Okay, now we wanna a duct for this area. Okay, 1, 2, and 3. So 1, 2, 3, 0.5 plus 538 plus 560. The total CFM is 2328.5. Okay, 25 inches. Duct. Round 25 inches. Let's take it from here. Here. Okay. So this is have to be very careful. You have to be careful. Okay, make it. Okay, now just before completing, you have to be careful that this is not, I think, is not good. You have to increase. You have to make it. Okay. Or 4. That must be attached to that. Okay. Just 2, 4. And this 2, 4. Okay. And this 2, 4. 2, 4. Yes. Okay. Now for this diffuser, make it and then go to the 3D, see, okay, see the distance, okay. Now this diffuser is good, and here has to become lower in the distance, okay. So the family is connected to the network, it can no longer keep it connected, okay. Okay, no problem. It increases the duct. Here is 560 and 538. Okay, is 30. The equivalent, sorry, is 19. Okay, we're gonna make it 20. Okay, now we have to get here 538. 15. Can make it 16 here. Okay, and 560. 15. Okay, we can make it the same, or it doesn't matter. And here is the last. Okay, now, gentlemen, for the air outlets, we're not gonna use diffusers. So here, the grilles, you have to get the available grilles in your market. Okay, so here we have many kind of grilles. We talked about the grilles in one of my tutorials, and the basics of its selection. You'll find many catalogs that provide you with the data. Okay, and let's take a look on the basics. We all remember this photo. This is from the Arabic tutorial of the engineer Osama Atif. So here is the airflow, and here is the width and the length and the throw at quarter meter per second, and effective velocity, pressure drop, and the decibel. So according to the most important parameter, you have to select the grill. And here is the air outlet, here is the air drop. We talked about this. And here is the air throw, so you can select the grill according to the air throw. It may be equal to the room length or 80% of it. Okay, and here is the occupied zone. So according to the available catalogs, you have to get the CFM, or the cubic meter per hour or liter per second, and the decibel. So our project here, the maximum I think is 45 decibels, so it's okay to use 35. And here the CFM, so the duct for 560 cubic meter per hour, make it cubic feet per minute, and here cubic meter per hour okay. 560 is 951, so it's gonna 951 cubic meter. Okay, so it's not enough, so I think this is enough to give you the required cubic meter per hour, and is 500 multiplied by 200. This is the width, and the length 500. Okay, so now the systems, air terminals, the grilles, supply grilles, maybe double deflection, whatever. Here okay, 12 diameter duct. Notice that we have here the diameter 16. Air terminal, just to get supply grill, curve rectangular and U face rectangular. So let's take a look on this. Okay, edit type, duplicate, use 500. Okay, okay, and now here you have to click here. So now we find that the grill is in its location. So this is the system that we have. Okay, notice that here is the grill, and here is the distribution for the diffuser, and here is the other diffuser, and this is the roof. And of course, if we have here a suspended ceiling, we're gonna use it to hide all this work. Okay, I'm just showing you the idea behind distribution systems. So for this, Also, we may use the same grille, system air, the same supply grille here. Okay. Now we have to do the same work for this side, and of course you can you may do something like this to distribute the air. This grille and this diffuser and this grille. This is another technique. So you have to know what is the best solution for your current system. Okay, it is not a rule. Yeah, let's see the other three. 514 4 plus 330 plus 123 0.5. What is the CFM? 2074.5. Okay. 24. But there is 24. Okay, so the best thing you may make here, and CFM 123 0.5 is 20. Oh, no, no, we have here a problem with the make this. This is 108. Has to be the same. Apply. Control Z. So we have here a problem with the visibility range. Okay. View range. This is not our diffuser. Okay. Also, there is a solution for this problem. Here, open this, make it 2, 2, and here is 1. So we'll find here our duct, our distribution, distribution. Okay. Notice that the neck is very small. Also, can make it like this. Okay, exactly like the other. So find here the neck. Now, okay, the last 330 plus 514 844 VFPM. Alright, and here is 17. Can make it 18. Okay, and here 330, 12. Notice that you can move this, or to recalculate the best location for the distribution diffuser here to avoid this problem. Let's say that we have here a duct. It's 12. Okay, so okay. And the other 514. 15. 15 or 16, whatever. Also have to know where is the best location for the grille, in the middle, or here, from here, or from here, or from here. So it's up to the calculations, the best calculation. You have to carry out many calculations before the real drawings, or before the Revit step. You have to draw the single line diagram, and to check out many solution categories or many solution scenarios. Okay, but here I'm just showing you how to calculate and how to draw. So here is this grille. For the selection of this grille, 330, 0 will be 560, 540. So also you can use this. Okay, the same. Here we have a problem. maybe a problem of the neck. Yeah, so duct pipe has been modified to be in the opposite direction, causing connections be invalid. Okay, so let's do it here to see. Okay, here is no problem. Oh. It's duct 12. Okay, go to the grill and for the neck, the type. Let's see another. Let's edit. Okay. Okay, gentlemen, let's try another size to see. Let's use this size. I got the same problem. So the thinking now is to increase this. Let's make it like this, and then use the same last and see what's gonna happen. Okay, I see that the problem is solved. Control Z. Let's see if this is gonna work or not. No. So try to increase it again. Okay, so as you see, that will work according to the minimum distance here. Okay, so you see that there is a distance. I think this is not good for this system, and of course, like I said, you have to move this duct to the right, make it in the middle to give the enough distance, not to make the grill like this. The grill, this tip has to be attached to the wall. Okay, but this is good to know what is the issues. Okay. Okay. The thickness, move it again. Make it here, and now we can decrease this. Just delete it. just add the duct. Five one four. Yes, 514 is 15. We did it 16, so it's not a problem. So let's see what is the required distance. Okay. And here is the duct. Okay. Control Z. I moved it wrong. Just be very careful. Okay. Add the duct. And okay. So you here have the grilles and the air distribution, the diffuser and the diffuser and the two grilles, and now we have finished. Okay, now we can see the 3D model here. Look, so here is the first, the third floor, and then this is for the second floor, this distribution. And notice that here we you can avoid these things by accurate drawing. Please, you have to know exactly the level. Notice that here is this level. Okay, make it cancel. So you have to avoid these things from the beginning. Look, so here another offset, and here offset. It will be difficult after finishing the duct, so please before doing any further details, you have to be sure about the offsets to avoid these kind of problems, because these things is gonna it's gonna be shown in the 2D. Here is, that's why we have here this thing. Okay. Okay, ladies and gentlemen, this is the tutorial about the grilles and how to select the grilles and how to draw the grilles. Notice that here also you can change these things as according to the architectural engineer and the width from the wall, and you have to be very careful. These things are very critical. Okay, here is the 3D. I know that it seems a mess, but the beauty of Revit that you can see every here is very good. Just need this, and here this means that there is a duct that's gonna goes to the down levels, and here is the ceiling too. We have here the other drawing. Okay, gentlemen, thank you very much. But before we close Revit, I'm going to talk about something in AutoCAD. We talked about Lisp drawing the duct 2D by using Lisp in AutoCAD, the previous tutorial. So what about the flexible duct? So load application here, flexible. Okay. And here we're gonna this place you have to make sure that the units millimeters. Let's make line like this, FLX 20 millimeters, 14 fins, and select this. We'll find this the duct like this, but so we have to use the polyline. Okay, FLX 20 millimeters, 14, and here we go. So this is the flexible duct. Thank you very much. Wassalamu alaikum wa rahmatullahi ta'ala wa barakatuh.